Okay, so here we have hopefully an opportunity that we don't want to leave behind, because one of the questions that we had asked is, some of these problems that we go over, have you seen them on an evaluation? Yes. So there would be a benefit to writing these down. We also had discussed that maybe volleyball players, football players, you watch film, right? So you are more familiar the next time you see them. That makes sense too. We all agree with that. Okay? But with these problems that we see here, both of them deal with pressure. Okay? So I'll just go ahead and read this just in case you can't quite see that on your screen. But this is based off of a problem that we were talking about before we hit record, that there was an accident over the bridge on the interstate on Highway 34 where these walls probably have to be rated to a certain amount of force, pressure, momentum before they structurally fail. Okay? So that's why something like this is so important. Okay? All right. So there's a lot of moving parts to something like this, just because why would you not want something like this to structurally fail? You don't ever want that to happen in engineering, but it does. Because fatalities could result from something like this. Okay? And that's nothing that we want to see happen to anybody around you. Well, to anybody in general, but especially if it's someone in this school, all right, or this community, or the state, well, whichever. Like we said, you don't want that to happen to anybody. But on racetracks, the walls are designed, I suppose it should say, walls are designed to withstand large amounts of pressure. If a 1,700 kilogram car is traveling at 65 meters per second and 0.1 seconds later, the momentum is 120,700 kilograms per meter over seconds. What is the pressure on this 0.80 meters squared wall? Okay, so that's the top one here. Okay, this bottom one, I think maybe you can read that a little easier. Yes, I understand there's a little bit of a glare here, but that's why we'll go ahead and read it. What is the mass of an industrial-sized propane tank? And we see 3 of them out here north of the school. Okay, so if we wanted to know what the pressure is on the ground, we would say as it lays level on the ground with 2.85 newtons per centimeter squared on the ground as the legs make contact over an area of 1,625 centimeters squared. Okay. Which one would you like to start with first? And maybe it doesn't matter. This one just looks like it's difficult because it's been so long since we've gone over them. Top one's probably a little more difficult. Which one would you want to work on together first? Bottom one? Okay, so the bottom one is what I heard first. Okay, so the 24th or 25th time now. We might get up to 50 times before the end of the semester, right, Mrs. Herbert? Okay, we're at 25. Well, the quarter just ended not too long ago. All right, so that being said, you've read the problem. What is the next thing you should do? Yeah, write it down. I mean, just starting writing it down would be a good place to start. This is maybe what's throwing some of you off. If something is measured in newtons, what is that? That is a force. If you have a measurement that is squared, like up here or down here, what is that measuring? That's measuring an area. So any force per unit area, in other words, if you have any force over area, what does that equal? Pressure. That equals pressure. So a newton per centimeter squared must be a pressure. You could also call it what we termed it as pascals. So you have 2.85 newtons per centimeter squared or pascals. Okay. So you correctly identified what variable is that. Okay, so we'll just go ahead and change it to the pascals. We've got a pressure here, whether you put zigzag, a smile, whichever. You can just leave it as a regular letter P. That's up to yourself as well. What else do we know in this problem? Okay, we know that there's an area, 1625. I mean, I'm just writing it because it's the only other number that we see. Okay, so there is our second number. And what is this asking? Okay, what is the mass then? Okay, so who would be, and I would speculate there'd be a lot of hands that go up, is I have no idea where to start. That's why we go over these, so that the next time you see something like this, you're more familiar with it. Okay, so the key is this Newton right here. Okay, that's what we have to unlock. Okay, because there is only one place to start, because we only have two of these numbers. Notice that we need to find the mass. That's what it's asking. So we don't know that. Okay, would we, since we see newtons, would we know what the force is? No, we don't know what the force is either. But here is a clue. Okay, since, you know, my drawings aren't the best, but you just have to bear with me. Okay, so there's our propane tank, and then, I don't know, I think these kind of form trapezoids. Now you don't have to draw this. So what we see, there's actually 4 of these legs. So there's 1, 2 in the front, and then there'd be 2 back of those. So where this is making contact here and here, as I circle that, that is the area that we're talking about. So that is pushing down on the ground there. So, but we want to know, well, what's the mass of this tank? Okay. So since it's sitting on the ground, it's going to have a specific weight. So when it has weight, it must have something upon it, and that would possibly be what? What gives any object its weight? Mass and weight are similar. Okay. What gives any object its specific weight on Earth? Gravity. So do we know the value for gravity?
9.8.
Yes, we do, because that's going to be important, because now when we look, oops, this is not a question mark. Now that when we see this in here, do we see force, acceleration, and mass in the same formula? We certainly do, okay? So what that means then is with our pressure formula, okay, I'm going to put this over here because I think you're going to be able to see this on here. Because what does pressure equal? What over area? Not time. Force over area. So what is our pressure according to how we set this up? I don't know why I'm pointing up here. I guess maybe at this, but what is our pressure? Did we set this up? Yeah, so what's our pressure then? 2.85. That's on the left-hand side. What's on the right-hand side of our equation on this fraction? It did. I was going to say it's in there, but it's on the bottom. So what unknown variable would be up on top? It would be your force. Okay? So now, how do we get force all by itself? Okay, so from all the way back to last August, first part of September, we're doing velocity problems. This is really no different. Here we got a velocity. Here you could say we've got a distance. In here we've got a time. How do we get rid of this fraction?
Do 2.85 divided by 1625.
Maybe. Okay. Did we change that value? No, we did. No, it's still 2.85. Maybe this makes it a little more clear. Okay. Right. So what is 1 times f?
1f.
Okay. So it's just plain f. I know why. This is fun. I don't know if this is force or if this is fun. You take your pick. Is this force? See? Okay, some of you are laughing. You will not break your face if you laugh. See, there we got another one. Los Angeles won last night. Yay, is that something where we... Yes. You wanted New York?
I just don't want Dodgers to win since they beat the Mets.
Oh, but that just means that the Mets they lost to a really good team then. Okay. Anyway. Okay. So whether we say this is a force or whether this is fun, we cross multiply. So what are we going to do with these two numbers then?
Multiply.
Okay. So what do we get when you multiply those two?
We have. Yeah.
How much? 4,631.25.
Yeah.
Now that's measured in newtons now. Okay? So are we getting close? This said we had to find the force. Now we found that.
We do force divided by acceleration to get mass.
That's exactly what you're going to do. Okay? Do we need to finish this now? Because now we know what to do. Because we've got our force, which is 4631. Okay? And then we've got 9.8 m, just like you said. So then you're going to divide those two, and that will give you your mass, which is approximately maybe 472 kilograms.
472.57.
472.57. That's what we get for this. So now we're back on track. Front row. Are we on the bus here? Second row. Third row. Okay, so for those of you who keep nodding your head yes or whichever, okay, you're telling me that you understand this. We see maybe some no's or something like that. If you're struggling with this, maybe for the 15th time, whose responsibility is that to ask for help? Okay, it's each individual's responsibility to do that. And I think you would agree with that. Okay, so now we move to the top problem. Okay, since it was 25 last time, now we're up to 26. Okay, you've read the problem. What's the next thing we should do? Okay, which there's going to be quite a few of them. Notice that this only had 2 numbers in it, but we had to find 3 unknowns first. Well, acceleration was probably a given. So what do we know in this problem according to our labels? Okay, what else do we know?
The time is 0.12 seconds.
Okay. Is there anything else we know? There's more numbers there.
Area is 0.80.
Now, notice that we had centimeters squared down here. We got meters squared up here. We said, for our purposes here, whatever area you're given, just keep it in there. We're not going to convert square centimeters to square meters or anything to that effect. Okay? So either one of these is fine for using pascals. Okay. What else do we know in this problem? Okay, what is our momentum?
12700.
Oh, that doesn't have a line over it. 120,700 kilograms per meter over seconds. Okay, so then we have a velocity which is, 65. Do we need to be more specific with that velocity?
It's initial.
Yes, we do. You are correct, but why are you right?
It says later the momentum.
Okay, so it's saying that it was traveling this at this speed, and then later the momentum is this. So that must mean that this came first. So will we be looking for a final velocity? Maybe, but probably because, excuse me, because what is the question ultimately asking for? What the pressure is. Okay? So that must mean what are two variables that you need to know to solve for pressure? Area is one, and force is the other. So now we know that we need to find a force. We're given the area, but in order to calculate a force, you need to know two things, right? How do we unlock this variable? Because what does force equal? Mass times acceleration. Do we have a mass? Yes, we do. Do we have an acceleration? No, we do not. Okay? So we can't find the force until we find the acceleration. Can we find the acceleration with this information?
P divided by M.
Okay? So what we're saying is with this formula, momentum equals mass times what?
Acceleration.
No.
Final velocity.
So our final velocity is something we need to know. So then, did everyone understand what your classmate said? Okay, so now we want to put this to use. In other words, by saying we've got 120, 700 equals, okay, what's on the right-hand side? So you,
17.
yeah, 1,700 and what? And what else? Now there's our final velocity. Okay, so how do we get VF by itself? You're going to divide each one of those. So 120,000, oops, 700 divided by 1,700. That gives you 71. And that is measured in what? Meters per second. So now we've got our final velocity. Now we can go up the chain here. Can we find acceleration now? Yes, we can. Okay? So in order to do that, we've got our acceleration, which equals what's on the right-hand side of your equation?
71 minus.
Okay? What we just found here, 71 minus 65. Okay? There's been probably a long time since we've had to do this. And then that's all over what on the bottom? Okay? So are we going to divide first? No, that's why we put the parentheses on there. Okay? So that is what? 6? I think. So 6 divided by 0.12. Do we get 50?
Yep.
So this is where the 6 comes from, subtracting these, divided by 0.12. our acceleration equals 50 meters per second squared. Okay? Now we've got our acceleration. Now what can we find? Now we can find our force. Okay? Which means we've got our force equals what we just calculated, our acceleration, 50 times what? Our mass, right? Mass times acceleration, 1780. Okay? What does force equal?
85,000. So, 85,000.
1,700 for the car?
85,000.
Oh, I'm looking at this. I don't know. Okay. So 1,700. Yep. Okay. So this should be 1,700. Okay. That solves a little, maybe some problems here. 1,700.
Where did 1780 come from?
I don't know why I did that. I was maybe distracted or something. So 50 times 1,700. So 85,000.
Yeah.
So then finally we have 85,000 in newtons. To find our pressure, how do we do that?
Divide area.
Okay, and our area is what?
0.8.
Okay, and that gives you 106,250.
Yep.
And that's measured in pascals. So I understand that's a large number, but you have to take into account we've got a large object, okay, a vehicle, and it's moving at this speed. Does anyone want to take a guess on approximately miles per hour that might be? I wouldn't expect you to know that, but you might. I would venture to think it's probably somewhere around 138, 140 miles an hour. Okay? Well, it was how you punched it in your calculator, right? 106,250. Okay? 106,250 pascals. Okay? You know, I can't remember if I've done this in the past. Maybe we should have you be able to convert meters per second to miles per hour. It's a whole long drug out. No, we don't need to do that. Okay, we kind of flipped things around here a little bit just because we know that in certain cases, it's going to be a late night for some people involved. Would we agree that that's correct? I think you would agree that if we want, I wouldn't say your full attention, but that this would be easier to work on today than what it would be tomorrow, correct? Yeah. So we started watching that unearthed video, okay? And one of the things that you see happening is they're going to take an obelisk that's made out of cement, and how are they going to get that into the mudroom? What do they call that?
A boat.
Well, that's they're going to move it from point A to point B, but that's not how they're going to get it into the mudroom. Well, not necessarily a cart. What were they making yesterday? They took a payloader instead. Yeah, they made a ramp. Okay. Well, I understand you could say that they cheated. But time is money. Okay. And I don't know when. So you know that these things had to exist, these obelisks, because there was a obelisk that was not fully harvested out of the ground. And just to look at something like that, was it rough or did it have smooth edges to it? So just think of the amount of time that it would have taken to even get that far to harvest that obelisk. And we're talking 400 years ago, I think, something to that extent. There was no steel. There is no power tools. So and they could use copper and maybe mix that with tin to make bronze. I mean, that's been happening for a long time. But what's the problem with using tools like that on granite? What did they illustrate in? It's just too dense of a type of rock. I never heard, was it dolerite? Dolerite. I never knew there was such a rock. Okay, well, there's probably more rocks that I don't know. But we talked about this yesterday. What are your 3 types of rocks? Did that jar anybody's memory? There's what? Sedentary, metamorphic, and igneous. Is that the 3?
Yeah.
Why didn't you say that yesterday then? Or maybe you did.
I wasn't here.
Oh, you did say that. I didn't say igneous.
I was thinking it when I was looking at science.
Okay. All right. So for next week, one of the things we're going to continue that video tomorrow. I don't know how much contact we're going to have tomorrow for sure, because we might just say, let's get this video rolling tomorrow. So I will formally assign your vocabulary. It will be due next week. So some of you might have it done already. Okay. Again, we'll continue that video. And how they get that in the mudroom, I'm convinced that they built the room first, then put the obelisk inside of there. Conventional wisdom today would say you would probably put the obelisk in there first, then build the room around that. But has anyone ever heard or seen the movie The 10 Commandments?
I've seen it. I haven't watched it.
Okay? Going way before your time, you probably haven't heard of Charlton Heston. Is that right? Charlton Heston? I think so. Okay? And what has happened is he portrays one of the Egyptian sons of the Pharaoh, Ramses. Okay? So what happens is during this movie, they show transporting these obelisks and then trying to get them to form upright. And I think it's probably pretty accurate on the number. They say slave labor, but I want to say it was thousands of them to do that. Because again, you're talking about 900 no. I don't know how heavy that obelisk was, but I want to say it was in the hundreds of tons. Because granite is such a dense rock, but to lift something like that is actually pretty extraordinary. Yes, you take the sand out from underneath it and then allow it to move up like this, then have ropes tied on both sides to get that set perfectly straight up and down. Because I would be led to believe that once you have that set, that's probably not going to tip over, just because it's just so heavy. So unlike that of different types of windmills that you might see over in Minnesota. So regardless, next week we'll also have some of your first problem solving assignments as well. I highly, highly recommend that you ask questions if you are having problems. Because if you don't, it just is not going to get any better. Okay? Until you address the problem. Okay? Anyway, so this top question now. Front row, are we on the bus here? Back row. Middle row. Okay? So for some of us, you have time to ask questions. So please do so. Okay? That's all I have. We'll catch up to you next time.